Dear friends, welcome to the second lecture of Java programming. So in this lecture, we will cover object-oriented principles and the key element of the object-oriented programming. So before we start, we should know that any program has two important key elements. What are they? Code and data. Right? Any program which you write, it has two main important key element, that is code part and data part. So let's talk about abstraction. What is abstraction? Human manage complexity. When you drive a car, you never think of that how many engines, how many parts are there in the engines, what are the parts for gear change. There are many parts, but you never think of. You just think that we hide the things, right? So abstraction, how we achieve abstraction in Java programming? So we just say it's a class car, right? I don't know much detail about internal details for this car, so I'm hiding the data, I'm hiding the details while making the abstraction, right? So this is abstract. Currently this is abstract. I don't know much detail of this car. So in abstraction, details are hidden, right? Now let's come to encapsulation. It is a mechanism by which we bind the code and data part together. How? By creating data member functions, data members as a private, public in the class. So we will see when we do programming in detail that there is a private keyword and there is a public keyword. What it does, when you define private data members, okay, so just remember, if you have any Java class or any of the class and you have two part, that is data member and member functions. Okay, so you have data member, that is data, and you have functions to manipulate those data. There is a class animal and there is a derived class over here, dog, right? So that animal is a base class and this is a derived class. All the property which animal class has, it will automatically come to the dog class. Dog class may have their own member function and data members also. So this dog has this capability also and plus their own capability. So this is what, if we look up from top to down, this is what we are doing, a specialization. In UML, maybe I'll put some unified modeling language, that UML language lectures. So I'll explain in detail that about a specialization. So from this class, if I look up and down the class, this is a specialization. I'm going in the specialization direction. That okay, I have an animal, and in animal it is dog. And when we look up from bottom to up, that is from derived to base, it is basically generalization. So this is generalization arrow, right? That dog is inherited from animal class. So this object-oriented principle inheritance is also one of the feature. So inheritance is achieved by making any class derived from other class. Now let's see the last one, polymorphism. What is polymorphism? Yes, polymorphism, you all know, poly means many and morphism means having the replica. So many forms. It is, polymorphism means many form. So how do we achieve this polymorphism, many form? Why do we require polymorphism? Okay, now let us suppose you have a stack of integer elements. So your program says you need to create a stack of integer elements, and your program says you need to, maybe at runtime also, you need to create a stack for floating elements also and char element also. So a normal programmer, what he will do, he'll make the stack class, and he'll make the stack class for what? He'll make the stack class for integer separate, he'll make the stack class for floating point separate, stack for character separate. I'm not writing anywhere the actual syntax, I'm just explaining the concept, right? So don't confuse that syntax is not clearly written. Okay, so stack integer, stack float, stack character. So I have made the 3 stack. But there is a problem. Why we are doing things again and again? And what if at run times I need to do these things? So there is a concept called polymorphism. In polymorphism, we may have a function which is overloaded. Like I'll create a stack, integer type, create a stack float type, right? So the name is same, create a stack, right? In this case the function name would be different. So there are 3 functions exist, but here the function is 1, but the signature is changed, right? So we are overloading the function. This overloading is a static, this is a static way of achieving this polymorphism. So there are 2 types of polymorphism. One is static polymorphism and then another is dynamic polymorphism. In a static polymorphism, we do operator overloading, function overloading, and that is come into picture while compile time only. During runtime, okay, this will be gray. There are some virtual function concept and many things that it is late binding concept. I'll explain later. Okay, just you understand, polymorphism means many forms. So I need to make a function for integer or float or any type. I should not worried about. I should worried about just calling the function. The function name should be same, or at runtime it will automatically override the definition. So how it is override the definition, how we will achieve polymorphism through Java programming, we'll see further. That's all for today. Please do subscribe, like and share. Thank you.